Welcome to another procedural texturing tutorial. In this one we're going to be creating a radial array node. It allows us to position as many things as we would like around in a circle, where we have control of the number of sectors, radius. We also have control of the rotation of our shapes. We have this fade that allows us to blend in between or have a completely hard edge. In the case of using a random output here, we also have a random size and rotation per section where we have a control of the randomness. We also have a random seed, and in that case we can use the fade to really blend between our shapes. So I think this one's going to be really useful for you in the long run, and I hope you enjoy it. I hope you learn something. Let's get stuck in. We're going to be using Blender 2.82, and we're going to be making sure, because we're working with nodes, that in our add-ons we have the Node Wrangler add-on enabled. I have my procedural texturing set up here, which just has a node space and a 3D viewport on the side. Make a new material, and we're going to be starting off with our object coordinates. Control H to hide, Shift Tab to snap. The outcome that we're after is to have some shape, potentially a square or a triangle, and we would like to array that in a circle so we can have squares or triangles or whatever it is, and we would like to be able to input the number. So in this case we would have 8 and it would give us this many, or we could also say 6 or 5 or 3 or 30 and it would give us that many of our objects arrayed in a circle. And the most common way that people do this is with something called polar coordinates, and the way the polar coordinates work is you have a crosshair and you have some distance away from the middle, and you also have some distance around. The way that people set this up in Blender is take your object coordinates, add a texture, gradient texture, set this to radial. Now that we have 0 to 1 going around in a circle like that, we're then going to take a convert vector map, set this to length, and this is going to give us 0 to 1 going out. So now if we take a converter, combine x, y, z, this will be our y, this will be our x. We now have a UV space. Now I'm going to append the shape group that we made in the first lesson. Shift A, group shapes. If we have a look at what this does, with a 0, 0 point in the center, we can have a shape fall off and size. Currently our coordinates do not have a 0, 0 point. So for us to be able to put some number of 0, 0 points on this, we need to move 0 in the y direction to 0.5. And we also need, instead of it just being 0 here, we need there to be some number. So I'm going to arbitrarily say that there are going to be 5 of our shapes. So we need it to be at this point, here, 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 and here. If we have a look at this, we have 5 discrete 0, 0 points. Let's put this into our shapes. Even though our points, there are 5 of them, and if we take our UV coordinates, we can see that we're drawing a circle here. So what's going on? Why is this a strange shape? And is there anything that we can do to change it? Well, we can put a little multiplier on the y coordinates, so now we can have some adjustment, but we're still not going to be able to make a proper circle. We can move this in or out, but as it gets too close to the center, it sort of gets sucked in. This is easier to illustrate what's going on with our squares. You can see that the issue is that we are bending our coordinates around the pole, around the center, and this is the key problem with using polar coordinates. Rather than having an undeformed UV on each of these points, we are having one which follows this circle. What we're going to be doing today is we're going to be working out a way to generate 5 or 7 or 30 discrete UV spaces and have them totally procedural so that we can have an input value and it'll react to that. What we're going to do today is we're going to be generating vectors for each sector. So when I say a sector, I mean that a section of this circle, this is called a sector. So what we're going to do, we want to have our plane, and we're going to take from our center point, we would like there to be sections, and each one of these sections wants to have a totally undeformed UV space in it. So for our solution, we're going to be taking our object coordinate and we're going to be translating them from our 0, 0 point out into each one of our sectors. Now, we need to know where each one of these sectors starts and finishes. We need to work out this angle to the center of each sector, and then from that we can work out the x translation and the y translation. This sounds fairly complex, but it's actually really simple for us to do. So take our texture coordinate, we're going to add a texture, gradient texture, we're going to set it to radial. So now we have 0 to 1 going around. What we need is to be able to set this upper value so that we can go from 0 to whatever value we want. Before we used 5, so this time I'm going to use 5 again. Just so that we can keep an eye on what's going on, I'm going to add an input value and I'm going to press N, change the label to sector count. count. Change this to 5. Now if you want to slide there, you'll notice that it's changing in 0.1s. If I press shift, it'll change in 0.01s. And if I press control, it will snap to whole integers. I'm going to bring it up to 5. At the moment we have our 0 to 1. We don't need to work with vector math in this instance because we're only using a single line of information, just black and white. We're going to go multiply by 5. Now what this has done is we have changed our maximum value here. So we're going 0 to 5. Add math, change this to snap. At the moment it's snapping at 0.5. I'm going to change that to 1 so that we are snapping in whole sections now. What we have here is an indexed list of the spaces that we're looking at. So we have space 0, 1, 2, 3, and 4. We don't want to work out the value to 0. We need to work out the value to halfway through this, which is going to be 0.5. And then halfway along this one is going to be 1.5, 2.5, 3.5, 4.5. So we're going to take our snap value and we're going to add 0.5. We're going to drop this onto the noodle. So now what we have is the halfway index. For us to turn this into an angle rather than just a number, we need to work out what the angle per sector is and then multiply it by the value that we have here. We're trying to get to the halfway point of sector 0, so we're going 1/5 of 2 pi multiplied by 0.5, 1/5 of 2 pi multiplied by 1.5, 2.5, 3.5, and so on. It needs to be responsive to our sector count, because if we had 7 sectors or 30 sectors, it would have to be 1/30th of 2 pi or 1/7 of 2 pi. So we're going to take our sector count here and we're going to take a math node. We're going to just duplicate this. In order to get 1/5 of 2 pi, we can put 2 multiplied by pi in the top socket. We can take our sector count, plug that into the bottom socket, and now what we have, the angle, this is outputting total angle per sector. We just need to multiply this by the value that we have per sector from this add. Duplicate another math node, set it to multiply, and put the divide into there. To go from having an angle per sector to having x and y translation vectors, we need to have a think about how we use trigonometry. Let's start off with a section. So here is our angle theta. Here is our center point that we're trying to get to. When we're working with vectors in Blender, the way that sine and cosine will output a vector is it will be normalized vector. So it will have a hypotenuse length. This length here will equal a value of 1. The way that we remember trigonometry is SOHCAHTOA. We are going to be looking at the opposite and hypotenuse, and the adjacent and the hypotenuse. This refers to the side which is opposite the angle or adjacent to the angle. We have a right angle triangle here. We have angle theta, which we've just worked out. So this is the angle to the halfway of each sector, and we need to work out what the x and the y translation is going to be. So we can use cosine, which is going to be cos theta is equal to adjacent over hypotenuse. We use a normalized vector, so hypotenuse is going to equal 1. So we can actually cancel that out and just say that that's equal to the adjacent in this instance, and we want to work out what the adjacent is so that we can take cosine of theta is going to equal the adjacent, in this case x, and equally we can say that sine of theta is going to equal the opposite, which in this case is going to be y. So let's take our angle. We're going to duplicate our math node again. First of all, we want to get the x. X is the adjacent, so we're going to take cos. Then we're going to take another one, Control Shift D, because we want the input noodle, and we're going to change this to sine. So if we have a look at this and this, you can see that we're getting some different areas. Shift A, converter, combine. Going to drop this on here. Sine goes into y, cosine goes into x. These are our translation vectors. If I just take an add, in this case we're using a vector output, so we're going to be using Shift A, converter, vector math. Then take our object coordinates, and we're going to add them to our combined vector here. Now at the moment all of our vectors equal 1, so that's why we're not seeing something here, because 1 is just outside, though we do see them in these other spaces. So I'm going to change the scale of our vectors here. Going to take another vector math node here, drop it onto that noodle, change it to scale, and now you can see that we can change the radius. Changing the radius is another thing that we're going to have as a value that we can keep an eye on. So I'm going to change this one to radius, and I'm just going to drop that radius value into our scale node here, and let's bring that down 0.5 just so that we can see it. So now if we were to take our shapes, now you can see the difference between polar coordinates, which are bending around a pole, and our undistorted vectors that we've created. As we increase this value, the maximum of our gradient texture increases because of this multiply. We're snapping them into sections. We are calculating the angle to halfway, and we are using that angle to calculate the translation vector. And then we are just changing the scale of that and adding it to our original texture coordinates. Just to make this whole setup more usable, I want to add in a whole load of functionality. I want to do something that the polar coordinates does automatically, which looks quite nice, is that you get this sort of out from the center look. The orientation of the shapes is all pointing towards the middle. As you can really see with the hearts, they all point towards the center here. Whereas we have a look at ours, they're all just pointing up and down. I also want to have a play with randomness. what we had a look at last time with adding white noise. The first thing I want to have a look at is how we can change our scale, because as we increase the sector count, you can see that these just end up overlapping. When we have 2 of them, that's totally fine, but as we increase, you can see they're starting to clip off the edge of our sectors. I would like to have some relationship between the scale of our shape and the sector count. After this add, I'm going to take this scale and I'm going to duplicate it, put it on top here. Now, as we increase the size of this, you can see that that is decreasing the size of our shapes. If we would take our sector count and we just plug this straight into the scale here, it gets way too small. I don't want it to be the full amount of the sector count, I want it to be some modification of that. So I'm going to take convert to math node, drop it onto that noodle, and divide this by 4. So now as we drop the number of sectors that we have, you can see that the parts are now getting smaller, so it's a little bit more responsive. The next thing I want to do is I want to have a look at how we can rotate these. So I'm going to take a vector mapping node. Last time what we did was we switched this over to texture. Texture basically inverts all of these scale, location, rotation from point. So point, you can think of it as affecting the UV points beneath, and texture works generally slightly more logically. For example, we can translate the texture in a positive or negative direction, and it also works slightly more logically with scale, where we have an increase or a decrease of the scale of our texture. However, when we have a look at rotation, whether you're rotating the points beneath or rotating the texture, you want it to be rotating clockwise or counterclockwise. However, because all of these are inverted with the texture input, as we increase the texture, you can see it's rotating anti-clockwise, which I don't want this to do. We're going to leave this on point because we're not using location or scale. This is in degrees on the mapping node, but when we take a combine XYZ and plug that in, suddenly this is in radians. Control H. We are looking at just rotating at the moment. I'm going to take another value here. This one is going to be called rotation, just so that we can keep tabs. Now I want to be working in degrees, so I'm going to add a converter, a math node, and I'm going to say 2 radians. Now I can put degrees in here. This will convert it to radians, which will put it into this combine XYZ. I'm just going to slot that underneath there and minimize it. H, or pressing this arrow, will minimize. I'm going to rename this mapping node to coordinates, and I want to make a new mapping node which is going to give us orientated coordinates. So I'm going to take our coordinates on our combine XYZ and I'm going to go Control Shift D. This has given us currently the same output. This one I'm going to rename from coordinates to orientated. And in order for us to do this, we need to change our rotation according to the angle per sector. I'm going to take off this manual rotation at the moment. If we just take our angle per sector, which we have here in this multiply, and we plug this into our Z here, don't forget this is already in radians. Let's have a look at our hearts, and you'll see that they all look a little bit strange. This is because this value needs to be inverted. So I'm going to take this multiply, drop it down onto this node, and I'm going to multiply it by -1. And now you can see they're sort of following each other around. I would like to be able to affect this with my rotation here. So I'm going to go multiply here, but I'm going to change this to add, and I'm going to take our to radians output, and I'm going to plug that in. So now you can see we can rotate this, and they're all orientated away from or towards the center. This last one that I want to generate is going to be a random one. Rename that to random. We're going to take a random value per sector. And for us to do this, we're going to have a look at our snapping here. This is giving us a single value per sector. And we're going to take a texture, white noise, from our snap into here. We're going to change from 3D to 4D. This is going to allow us to have a random seed to generate random values per sector. I want this to randomly change the rotation. So at the moment we have values between 0 and 1. We need values between 0 and 2 pi. So I'm going to take another multiply, duplicate this, drop it on, multiply by 2 times pi. And now we have values between 0 and 2 pi. If we put this into our Z rotation on this random output, let's go and have a look at our hearts, take this vector and drop it into here. Now what we've got is a random rotation per sector. On our node here, we're going to do Control H, and we're going to change the scale. Because we're not controlling the rotation in this instance, I can change this to texture. So now when we change the scale up, the size increases, and down, the size decreases. This is important because when we duplicate our next white noise texture, so we have 1 for rotation, we're going to give seed 0. We're going to have 1 for scale, which we're going to give seed 1, so that we have a different seed per transformation. This value is between 0 and 1. So if we left this on point and we plug our scale into the scale here, let's have a look at our hearts. Some of them get really big. If I change this to texture, then some of them get really small, and that's much more what I want. We don't want this to get too big for their sectors. I'm going to want to put in a mix RGB so that I can have a control on the amount of the random transformation. Color, mix RGB. We want our rotation, this bottom one, to be between 0 and our random amount. So mix goes into slot 2. Slot 1 is black, and this now goes into our rotation. So now if we increase or decrease our factor, you can see that we go from 0 rotation to random rotation. For our scale, we're going to do the same thing. We're going to put this into color 2, but in this case we're going to go up to a scale of 1. So now there is either full size or some amount of that randomness. A little tip, if you want to have these factors joined, rather than using a value, which you could totally do, you could totally plug this into both of your factors and you could have this increase. But you can see that this increases to any number. We only want to be sliding between 0 and 1. Instead of doing that, what I'm going to do is I'm going to add a color invert. This has a factor on it, so I'm going to use this as our factor here. So there you go. Now you have a factor that you can control both of these with. I also want to have a random color per sector. This is just going to be an output so that we can use it outside the node. I'm going to add an additional white noise texture. Control Shift D, change this one C to 2, and I'm going to be adding a color hue saturation. I'm going to change the color in here to be 100% saturated and 100% value. So now as we add some white noise value to the hue, we'll be getting a transformation around between 0 and 1, so around the color wheel. This is our random color. We have a random rotation and scale, normal coordinate, and an orientated coordinate. I would like to add one more feature, and this is a fade between sections. At the moment we have this really hard edge, and I don't want to have that. I want to have it sort of blending. Now in order for us to do this, we need to think about where we are inputting our change here. And it's actually way back here. It's just after this gradient that we are going to be adding something. And that something is going to be a noise texture. So we're going to go Shift A, texture, noise. We're going to be adding a color mix RGB. And we're going to take our gradient texture and we're going to go into the first one. And now this is our new value in here. We're going to be taking our noise texture, which you can see here. Detail is the biggest thing that messes up computation time. So turn that to 0 and it's going to speed it up a little bit. We're going to take our factor. We're going to put that into the second socket of our mix node here. And we're going to change from mix to linear light. So we're not mixing between them, but we are affecting our radial gradient by our noise texture. Let's just have a think about how this is affecting. So let's go to our snap. As we increase this, you can see that it is basically bending the edge. And the reason it's doing that is because you have some addition and some subtraction across the whole thing. And then when it is snapping, you get a slight variation in where the snap is happening. Now, instead of this being set to 5, because we want this to be a very, very fine diffused kind of fade, we're going to set this to 5,000. Now, if you zoom way, way, way in, you can still see that this has the noise texture, but from a sort of normal working distance, it's not really going to show up. If I was to change this to 50,000, you can see it's not actually really changing much how it looks in the viewport. If I go on to cycles, you can see it sort of dissolves away slightly, but you still get that dotty look. So now you can see that we've got this linear light affecting a blur here, and as we just increase that slightly, we're getting that motion. Now, the reason that we use linear light rather than, for example, add, if we have a look at what this does, this will rotate our sections. When we use linear light, these sectors do not change position, they just lose their edge slightly. Now, what does this mean for our shapes? Well, as soon as we start adding a little bit of that blur, you can see that we get a little bit of softness, but it also means that rather than having a hard clip, you can sort of get back some of that edge. You can obviously go way too far and the whole thing will just become a mess. What we need to do is we need to put this into a group node. I'm going to select everything, Control G, tab out. I'm going to rename this Radial Array. I like to have texture coordinates on the outside, just because if you have texture coordinates on the outside, then this can become part of a bigger system. So that is going to be my first thing to add. Go Shift right click to add this reboot. And this is because I want to go from my group input straight to that. I'm going to change the name to vector, delete our texture coordinate here, and I can put our vector into the vector of our group node. I'm also going to start generating some outputs. So we have coordinates, orientated, random, and we've also got a random color. So now if we have a look at the outside, we have a coordinate per section, an orientated coordinate per section, a random coordinate per section, and we also have a random color per section. So if I take orientated and then plug that into my shapes, and then I maybe want to add the random color, we can take a color mix RGB. Let's plug hearts into the factor. The first socket is going to be our color and the second socket is going to be our background color. Let's take the random color to the first socket and we're going to put the background to be black. Let's have a look at creating our other inputs. Shift right click across here to bunch these up together, and I'm going to go from my transparent socket to this one. I'm going to set a default value to 5, a minimum value to be 1. I'm going to change the input to sector count. I'm going to do a shift right click on my radius, connect it up. Rather than just having a sliding scale for rotation, I'm going to have it on one of these factor sliders. Grab a transparent socket, and I'm just going to plug this into the factor of my linear light here, and I'm going to cut it. Control right click to bring up the scalpel there. So now what I've got is I've got a factor. I can change this factor's name to rotation, and I'm going to go from 0 to 360. Do a shift right click, that will create the reroute. I'm going to grab the rotation, and I'm just going to plug it into that reroute. So now on the outside, you can see that we've got a nice little slide that rotates between 0 and 360 degrees. We have a few more things that we want to add. We have here a slider for our random amount. A new socket. is going to go into this factor, do X to delete those, and then take this factor input up to this mix, shift right click to create the reroute, drag it onto that one as well. So now what we've got is a factor input. I'm going to rename to randomness. We want to add a seed and a fade. One of the big things about our randomness is that it is controlled by a seed. So I'm going to go into here and I'm going to create a system that will give us a different seed per white noise texture. So again, transparent socket goes to my first white noise here, rename to seed. Now I'm just going to plug this into all of them, but each time I'm going to go convert math add 1 to the different randomness remains different. The last thing we want to do is we want to implement our blur. Let's add a factor again, give us a slide. I'm going to rename this to fade, and I'm going to add a multiply. I'm going to drop it onto the correct noodle here, the one that glows when you hover over, and I'm going to divide by 3. So now our maximum fade is only going to be 1/3. Kind of want the fade to be up above this randomness stuff, so I'm going to drop it up to just with that up button there. So that's all set up now, this whole thing. Hopefully this has been a useful video and you've learned something. This, I think, is quite a useful node for understanding how we can intentionally generate translation vectors, whereas previously we've used just a random number to transform our textures. But in this instance, we wanted to do a very specific task and we were able to use maths in order to generate those vectors. So there we have it. That's all from me today. Hopefully this has been interesting and you've learned something. Let me know what you think down below, and I'll be back next week with another tutorial. So thanks for tuning in. I hope you've enjoyed it. I'll catch you next time.